Hello, everyone. This is Mr. Chang. I think we won't have time to meet, but I'd like to go over this with you for the permutation and combination. And also, I have one more lesson to teach, which is on the binomial theorem. How do you expand a binomial expression very quickly? All right. So I think the best way is to just make you a video, and you can watch it over and over again, and it will save everyone time. Now, in the diploma exam and also in the mock exam, there are 6 questions in total for this unit. So 6 questions, that's 15%. That's a lot. And I think there will be 4 questions, at least 4 questions on permutation and combination. So that's 10%. And then 5% will be on binomial expansion. So I think it's worthwhile to learn it now. And then we can we can earn those 15%. Okay, let's do the quiz. So let's use the quiz as a way to relearn some of this concept. Okay, and I'll make you another video for the binomial theorem. All right, and then I will make it very quick. Okay, so it won't waste a lot of time. Okay, so food combination. This is a fundamental counting principle questions. You want to order dinner. So this task has 3 stages. First, you have 2 choices for ordering salad or soup. And then the second stage is you have 4 kind of meats to choose from. And final stage is you have 2 kind of drinks you can pick. So therefore, the answer is 16. All right. Next, when you arrange things on the shelf, arrangement is an indication, is a hint for permutation question. All right, arrange something, and then the order is important. You have 10 different books. To put 6 of them is 10p6, whatever that is. All right, so if I'm using formula, so that's 4 factorial. So you can just put that in your calculator, but I'll just like show you what does that equal to. So whatever answer you get in your calculator, or you can just punch this in your calculator. Okay, so that's the answer for the second one. All right, for the third questions, so number and code. All right, so odd numbers. So these are also permutation questions, or just use fundamental counting principle. You want 4 digit, 1, 2, 3, 4. So to write a 4 digit number, there are 4 stages. You need to write down 4 numbers. Um, how many choices are there in each stage? You always start with restriction. So being an odd number, or your last digit have to be odd. So we start with that restriction. So you have 5 choices, 1, 3, 5, 7, 9. And then also another restriction is the first one cannot be 0. Okay, repetition is allowed, so you just go from 0 to 9. The 10 digit you can't be 0, so there's still 9 choices. The middle 2 there's no restriction, so you just multiply them. Okay, so this way you get the answer. When repetition is not allowed, we follow the same thinking. Can't be it can only be odd digit for the last digit. You always start with restriction first. This one can't be 0 and can't be the last digit. So instead of 9, you have now 8, because can't be 0, can't be the last digit. The last digit since is odd number, it won't repeat 0. So can't be any one of the odd digit, can't be 0, so you have 2 less choice. So it's 8. Now the second digit can't be the first, can't be the last, so it's down to 8. And then the third one can't be any of these 3, so it's down to 7. Okay, so whatever answer you put in the calculator. Okay, now committee questions. Okay, so I have some varieties here. So there are total 18 people. Any 4 can be chosen, no restriction. So 18 people, you just choose 4. Committee question is always a combination question, unless you have row. Okay, you see in the last example. Okay, so just put this in the calculator, whatever the answer is. How many committee with 2 boys, 2 girls? Okay, easy. 10 boy, you choose 2. All right. 8 girls, you choose 2. So total 18 people, you're choosing 4 from them, but there's some restriction. They have to be boys, they have to be girls, all right, and then you must just multiply the answer. How many ways can a committee with a chairperson, vice, treasurer, and a secretary can be chosen? When you have a specific role, which means even you have the same 4 person like A, B, C, D, if they are given a different position, they are considered a different committee. So which mean order is important here. So this become a permutation question. So you can just do 18C4, 18P4, sorry. That would be the answer. 18P4 is the answer. All right. The other way to think about this is use fundamental counting principle. Okay, you have four positions. How many people you can choose for the chairperson? Well, there are 18 people to choose from. How many people can be chosen as the vice? Well, once you choose a vice, well, I don't think the chairperson will also be the vice, so it's down to 17. How many can be the treasurer? Well, it won't be the first two, so that's down to 16. How about secretary? There's 15. So also this will give you the same number. Okay, well, this is actually same as 18P4, but you don't need to write that. Okay, either way, all right, you don't need to put it in the P or C or format, whatever ways that will give you the answer. All right, finally, let's say you have a question, say, just expand on this. Let's say you want two boys and two girls. Let's say it's the same questions. However, um, let's say Kathleen has to be on the committee. Has to be on the committee. Okay, well, she's a girl, so we know. So, out of these four people, Kathleen has to be on it. Then how do you do it? Well, there's only one Kathleen in this world, very unique. One Kathleen, you choose one, right? This is how you choose Kathleen. There's only one way to pick her. And then let's choose the boy. Well, you still have 10 boys to choose from, so 10 choose C. Let's choose the last girl, like one of the girl is Kathleen. So what's the last one? Well, do you write 8 choose 1? Well, no, right? Kathleen is one of the girls, so now she's being chosen. How many girls are there? There's only 7 girls, and you only need to choose one. All right. So out of the 18 people, you're still choosing 4, but then you have like one designated person, like Kathleen, have to be there, and then this will be your combination. Okay. So I'm just giving you another variety so that the question is won't be that straightforward. I think that's kind of too straightforward. In the diploma exam, maybe they will put some kind of like restriction like this to make it a little bit challenging. All right, moving on. Combination, okay, notation questions. Okay, using the formula, this is equal to n factorial. N is whatever the numbers here, over this minus that factorial. Okay, so simplified it is this. Simplified it so that there's no factorial sign. So which number is bigger? The top number is bigger. So start from that number, keep going down, keep going down, keep going down until you see a same thing. You stop, put a factorial sign there, and then you cross out. So here is the answer. That's the answer. You don't need to expand it. Okay, next one. NC2, according to the formula, is this, right? Just using the formula will be given in the exam. All right, so let's expand it. N minus 1, n minus 2. Okay. 2 factorial is just a 2. Okay, so this part cancel out. What do you do with the 2 here? Put it on the other side. Okay, go away the clock. So n times n minus 1 equal to 30. 6 times 5 equal to 30. So n is 6. Okay, here we go. Okay, pathway questions. So what do we do here? Pathway questions. Pathway questions. Pathway questions with some hole in between. So let's start from 1. So you just put 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, just along the edge here. Okay, and then every junction, every node, you can either go from here or there. So you just add the sum of the previous steps. 1, 1 give you a 2. 1, 1 give you a 3. A 2, 1 give you 3, 3, 1, and so on. Just add the previous step. Here, same thing here. All right, what do I do here? Well, to get to this point, you have to go from this point. There's only way. So you just copy the number over, just like how you copy the one along the side. You copy those number because there's only one way. Same here. This point have to be from there. So you just copy this number. However, the next point, 4 and 4 give you 8. All right. So this point is 4 plus 9 is 9. Okay, this point is you can only get from there. So you just copy the 9 over. 9, 7 give you 16. All right. 5, 4 is the 9. 8 is the 17. This is a 17. 17 and 34. Okay, this one, oh, I just copy a 9 over. 9, 16. 17, 9 is the 26. 34, 26 is 60. This one plus this one is 42. 102. The answer is 102. Okay. All right. Next, letters arrangement. Okay. So there are total mathematics. There are total 13 letters. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, sorry. 11 letters. All right. To arrange them, 11 factorial. Well, there are two M's, there are two A's, there are two T's. So that's what you do. Okay? Like ignore the letters still disappearing. Okay, here we go. And then just do it in a calculator. When you put the M's together, which means you bound them together. So instead of 11 letters, you put the two M's together, MM become one letter. So there's only 10 letters to arrange. And MM, doesn't matter MM or MM is the same thing, so there's no other permutation. Just put 10 factorial. And then there's still 2A, there's still 2T. There's no more 2M's. It's grouped together. Last one, HIS have to be together, so group them together. HIS is one group. So there are total only 9 letters there because you group the 3, there's still 8 remaining. HIS is 1, A plus 1, there's total 9 permutation, arrangement. But for each HIS, it could be HIS, HSI, IHS, ISH, SIH, SHI, and so on. So there's 3 factorial for each HIS. So you just put it like this, and now there are 2M, 2A, and 2T. Okay, so that's your answer. All right, final questions. We're almost done. Okay, 5 cards, all hearts. So there's only 13 hearts. You choose 5. You need 5 cards at the end. So make sure like this number is 5 at the end. So that's the answer. 3 A's, 4 2's. There are 4 A's, you choose 3. There are 4 2's, you choose 2. So there are only 5 cards. There are total 5 cards you choose from. There's only like 4 A's and 4 2's you can choose from. Okay, exactly 2 pairs. It doesn't say any pair. So any pair is 4C2. There's 1 pair. Well, it could be any pair. So times it by 13. A second pair is another pair, 4C2. But it can be any of the pair that is not the first pair. Otherwise, you have 4 of a kind. So there are another 12 choices. Okay, so you have 4 cards so far. You need 5 cards. So one last card. The last card you won't repeat any of. This is a 4 here. You won't repeat any of the 2 rank here in the first one. Otherwise, you have a full house. So you take away 8. 52 take away 8 is 44. You choose the last card. So you total you have 5 cards. All right, which give you 2 pairs. All right, a flush mean is like all hearts, all club, all space, or all hearts, all diamond. So this is any one of a kind, one of a suit. You can have any one of 4 of them. So just times 4. Okay, at least 3 king, which means 3 kings, 4 kings, 3 kings or 4 kings. Okay, the 4 kings you choose 3. Well, there's only 3 cards. You need 2 more. They can be non-kings. So 48 choose 2 non-kings. Very annoying. Plus, you can have 4 kings. 4 choose 4. 48 choose the remaining cards. Don't forget this part. You need 5 cards. That's the answer. All right. At least 1 queen. You can do either 1 queen, 2 queen, 3 queens, or 4 queen. That at least 1 queen. But that's very long. How about the opposite, which is no queen? And then we can do the opposite. First, no restriction. 52 cards, choose any 5. And then take away the case when there's no queen. While queen, non-queen is 48, non-queen, you choose 5. So which means no queen. So this will give you the same answer as in you do the 4 cases. Okay, so it's a bit fast, but it's nothing new. Everything is same as 48. Everything is same as the one in your textbook. All right. So hopefully by doing this a second time, you know how to do it now. All right. I'll mark your quiz, but it won't worth a lot. It's just a quiz. Hope you will do well in the mock exam. There will be 4 questions in this topic, 10%, and then I will send you another video about the Pascal triangle and binomial expansion tomorrow. All right. Talk to you. Bye.